What is Prometheus and why is it used?
Prometheus is an open-source monitoring and alerting toolkit originally built at SoundCloud and now a CNCF graduated project. Core strengths. Pull-based model scrapes metrics over HTTP, giving the monitoring system control over what and when to collect. PromQL, a powerful, purpose-built query language for time series analysis. Multidimensional data model. Metrics are identified by name and key-value label pairs. Built-in alerting via Alert Manager with routing, grouping, and silencing. No external dependencies, single binary with an embedded TSDB, time series database. Common use cases: monitoring CPU, memory, disk, and network usage across infrastructure. Tracking application-level metrics, request rate, error rate, latency, the RED method. Alerting on SLO breaches such as high error rates or P99 latency spikes.
How does Prometheus collect data?
Prometheus uses a pull model. It scrapes metrics from HTTP endpoints, typically
/metrics.
at configured intervals, target discovery methods, static config targets listed directly in
Prometheus SIML.
service discovery, dynamic discovery via Kubernetes, console, EC2, DNS, file-based SD, etc. Example scrape configuration.
Prometheus SIML.
Tag.
Code scrape configs, job name, node exporter, scrape interval, 15s, static configs, targets, localhost, 9100.
For short-lived jobs, batch, cron, use the push gateway since they may not live long enough for Prometheus to scrape.
What is PromQL?
PromQL, Prometheus Query Language, is used to query, filter, and aggregate time series metrics stored in Prometheus. It powers dashboards, alerts, and recording rules. Key concepts: instant vector, a set of time series with a single sample each, for example. A range vector, samples over a time window, for example.
HTTP total 5M.
AI functions.
Right.
Eh.
Increase.
Eh.
Histogram quantile.
Eh.
Avgo vertime.
Etc. Example queries, per CPU mode usage rate.
Code rate, node per seconds total mode equals user 5M.
Per second request, rate over 5 minutes.
Code rate, HTTP total 5M.
95th percentile latency.
Code histogram quintile, 0.95, rate, HTTP duration seconds bucket 5M.
What are Prometheus exporters?
Exporters are agents or libraries that expose metrics from third-party systems in a format Prometheus can scrape. Common exporters: node exporter, Linux/Mac OS hardware and OS metrics, CPU, memory, disk, network. Black box exporter probes endpoints over HTTP, HTTPS, DNS, TCP, ICMP. MySQL exporter, database performance metrics, queries, connections, replication lag. C-Advisor, container-level resource usage and performance metrics. Kubestate metrics, Kubernetes object state, deployments, pods, nodes. You can also instrument your own application code using client libraries, Go, Python, Java, etc. to expose custom
/metrics.
endpoints directly without needing a separate exporter.
How do you set up an alert in Prometheus?
Alerts are defined in alerting rules files and evaluated by Prometheus, which fires them to the Alert Manager for routing and notification. Example:
Alerting rule XML.
Tag.
Code groups name, instance down, rules, alert, instance down, expert up equals 0, 4, 5M, labels, severity, critical, annotations. Summary, instance $labels instance is down, description, $labels instance of job $labels job has been down for more than 5 minutes.
Key fields:
Expert.
the PromQL condition that triggers the alert.
4.
How long the condition must be true before firing, avoids flapping.
Labels.
Attach metadata for routing, for example.
Severity. Annotations.
Human-readable descriptions with template variables. The alert manager then handles deduplication, grouping, silencing, and routing to channels like Slack, PagerDuty, or email.
What is Grafana?
Grafana is an open-source observability and visualization platform for building interactive dashboards. Key features: multi-data source support, Prometheus, Elasticsearch, Loki, InfluxDB, CloudWatch, PostgreSQL, and 100+ others. Rich visualization, graphs, heat maps, gauges, bar charts, stat panels, logs panels, and more. Unified alerting, alert rules that can query any data source and route to Slack, PagerDuty, email, webhooks, templating variables, dynamic dashboards with drop-down filters. Provisioning, dashboards, and data sources can be managed as code via YAML/JSON, plugin ecosystem. Extend with community and enterprise plugins for panels, data sources, and apps. Grafana is typically paired with Prometheus for metrics and Loki for logs, forming the ELK Stack: Prometheus, Loki, Grafana.
How do you connect Grafana to Prometheus?
Via the UI, 1. Log into Grafana default.
http://localhost 3000.
2. Navigate to configuration, data sources, add data source. 3. Select Prometheus. 4. Enter the Prometheus URL, for example.
http://localhost 9090.
5. Click Save and Test to verify connectivity via provisioning infrastructure as code approach. Create.
Provisioning/data sources/Prometheus YAML. Code API version 1. Data sources name Prometheus, type Prometheus, URL http://Prometheus 9090. Access proxy, it is default true.
The provisioning approach is preferred in production since it's version-controlled and reproducible.
What are Grafana panels?
Panels are the building blocks of Grafana dashboards. Each panel visualizes data from one or more queries. Common panel types: time series, line/area/bar charts for metrics over time, the most commonly used panel. Stat, a single large numeric value with optional sparkline. Gauge, progress bar or dial showing a value relative to thresholds. Bar chart, categorical comparisons. Table, tabular data with sorting and filtering. Heat map, density visualization, great for latency distributions. Logs, displays log lines from Loki or Elasticsearch. Node graph, network topology, or dependency visualization. Each panel supports thresholds, color changes at certain values, overrides per series styling, and transformations, join, filter, calculate across queries.
How do you create alerts in Grafana?
Grafana's unified alerting system, introduced in Grafana 8+, supports multi-data source alert rules. Steps to create an alert: 1. Go to Alerting, Alert Rules, New Alert Rule. 2. Define the query, for example, a PromQL expression. 3. Add reduce and threshold expressions, for example, last value 1000. 4. Set the evaluation interval, for example, every 1M, and pending period, for example, for 5M. 5. Configure labels for routing, for example.
Team equals backend. Severity equals warning.
6. Set up contact points, Slack, email, PagerDuty, etc., and notification policies for routing, alert states: normal, pending, firing, no data, error. Alerts can also be provisioned as code using YAML files for GitOps workflows.
How do you configure a Grafana dashboard using JSON?
Grafana dashboards are internally represented as JSON and can be exported, version-controlled, and imported. Export, dashboard settings, JSON model, copy. Import dashboards, import, Paste JSON or upload file, example JSON snippet.
Code, dashboard, title, my dashboard, panels, type, time series, title, CPU usage, targets, expert rate, node seconds, total mode equals user 5M, legend format, instance, grid pos x0, y0, w12, h8. Learn.
Best practice, use.
Grafana dashboard provider.
In provisioning to load, JSON files from a directory automatically, keeping dashboards in Git.
What is the ELK Stack?
The ELK Stack is a popular open-source log management platform consisting of 3 components: Elasticsearch, a distributed search and analytics engine that stores and indexes log data; Logstash, a server-side data processing pipeline that ingests, transforms, and forwards logs; Kibana, a web-based visualization and exploration UI for Elasticsearch data. The modern version is often called the Elastic Stack, which adds Beat's lightweight data shippers as a 4th component, typical flow.
Code applications, Beat/Filebeat, Logstash transform, Elasticsearch store/index, Kibana visualize.
ELK excels at full-text log search, log analytics, and security event monitoring, SIEM.
What is the role of Elasticsearch in ELK?
Elasticsearch is the core storage and search engine of the ELK stack. Key characteristics: distributed architecture. Data is split into shards across nodes for horizontal scaling. Inverted index enables fast full-text search across billions of log lines. Res tful IPI, all operations, indexing, querying, cluster management. Use HTTP/JSON. Near real-time, documents become searchable within -1 second of indexing. Query DSL, a rich JSON-based query language supporting full-text search, aggregations, filters, and fuzzy matching. Elasticsearch stores data in indices, where each index contains documents, JSON objects, with fields that can be mapped to specific data types, keyword, text, date, integer, etc.
How does Logstash work?
Logstash processes data through a 3-stage pipeline. 1. Input reads data from sources, files, Beats, Kafka, Syslog, S3, databases, etc. 2. Filter transforms and enriches data, parse, mutate, drop, add fields. 3. Output sends processed data to destinations, Elasticsearch, S3, Kafka, stdout, etc. Example configuration.
Logstash conf. Code input file path equals /var/log/syslog, filter, grok. Match equals message equals %syslogtimestimp, timestamp %sysloghost, host %diti, program, %greedyditi, log message, date. Match equals timestamp, mmMDHH, mmSS, mmMDDHH, mmSS, output, Elasticsearch, host equals localhost, 9200, index equals syslog %+ yyyymmdd.
Common filter plugins.
Grok,
Pattern matching.
mutate,
Rename/remove fields.
date,
Timestamp parsing.
geoweb,
IP geolocation.
JSON.
Parse JSON.
What is Kibana used for?
Kibana is the visualization and management UI for the Elastic Stack. Core features: discover, search, and browse raw log data with filters, saved queries, and field-level exploration. Dashboards combine multiple visualizations into interactive, shareable dashboards. Visualize/lens, create charts, line, bar, pie, heat map, etc., using drag and drop or the full Visualize editor. Canvas, pixel-perfect, presentation-ready reports with custom styling. Alerts, rule-based alerting on log patterns, thresholds, or anomalies. SIEM/security, threat detection, investigation, and incident response. Machine learning, anomaly detection on time series data. DevTools/console, execute Elasticsearch queries directly.
How do you install the ELK Stack?
On Debian/Ubuntu, IPT.
Code #add elastic GPG key in repo, wget qo https://artifacts elasticco/gpgk ey elasticsearch sudo apt key add. Echo deb https://artifacts elasticco/packages/8 x/apt stable main sudo t/etc/apt/sources list d/elastic 8 xlist sudo apt update #install components sudo apt install elasticsearch logs-kibana #enable and start services sudo systemctl enable now elasticsearch logs-kibana.
With Docker Compose, often preferred.
Code services Elasticsearch. Image Docker Elasticco/Elasticsearch/Elasticsearch 8.12.0. Environment Discovery type equals single node. Ports 9200. Kibana Image Docker Elasticco/Kibana/Kibana 8.12.0. Ports 5601.
Verify.
Curl x get localhost 9200.
Should return cluster info. Kibana is available at
http://localhost 5601.
What is an index in Elasticsearch?
An index is a logical namespace in Elasticsearch that holds a collection of documents, JSON objects. It's analogous to a database in SQL. Key concepts: each document has an
ID
and fields with defined data types. Mappings define the schema, field types, text, keyword, date, long, etc. An index is split into shards for distributed storage and parallel querying. Create an index with settings.
Code curl x put localhost 9200/logs h content type application/json d settings number of shards 3 number of replicas 1 mappings properties timestamp type date level type keyword message type text
Naming convention. Use time-based names like
logs 2024.0 1.15.
with index templates and ILM for automatic rollover and retention.
How do you send logs from Logstash to Elasticsearch?
Define the Elasticsearch output plugin in the Logstash configuration.
Code output Elasticsearch hosts equals http://localhost 9200 index equals logs % plus yymmdd user equals elastic password equals $ease password.
Key options.
Index
Target index name supports date math for daily indices.
user
/
password
authentication credentials required in Elastic 8, X with security enabled.
SSL certificate verification.
Verify TLS certs when connecting over HTTPS.
Pipeline.
Specify an Elasticsearch ingest pipeline for further processing.
Template name.
Apply a custom index template for high-throughput environments, tune.
Flush size.
Batch size, and
Workers.
parallel output threads to optimize indexing performance.
What is a Kibana visualization?
A Kibana visualization is a chart, graph, or data display built from Elasticsearch queries. Common visualization types. Line chart, metrics over time, for example, CPU usage, request rate. Bar chart, categorical comparisons, for example, logs per service. Pie/donut chart, proportional distributions, for example, error types breakdown. Heat map, density across 2 dimensions, for example, request latency by hour. Metric, single aggregated number, for example, total error count. TSVB, time series visual builder. Advanced multi-series time visualizations with math expressions. Creating a visualization, 1. Choose the visualization type, 2. Select a data source, index pattern. 3. Configure metrics, count, AVG, sum, percentiles. and buckets date histogram terms filters. 4. Save and add to a dashboard.
What is Filebeat?
Filebeat is a lightweight log shipper from the Beats family that reads log files and forwards them to Logstash or Elasticsearch. Why Filebeat over Logstash for collection? Minimal resource footprint, ~10 to 20 MB memory. Built-in backpressure handling slows down if the output is overwhelmed. Registry file tracks read positions, ensuring no log lines are lost or duplicated after restarts. Example configuration.
Filebeat TIML.
Tag.
Code Filebeat inputs type log enabled true paths /var/log/syslog /var/log/auth-log multiline pattern \d4\d2\d2. Multiline negate true multiline match after output Elasticsearch hosts localhost 9200 index Filebeat %+ EIM MDD.
Filebeat also has modules Nginx, Apache MySQL system that ship with pre-configured inputs, parsers, and Grafana dashboards.
What is the difference between Logstash and Filebeat?
Filebeat, lightweight agent, ~10 MB memory. Reads and forwards log files with minimal transformation, runs on each server as a sidecar or daemon set. Built-in modules for common log formats, limited filtering. Can add fields, drop events, simple conditionals, Logstash. Heavyweight processing engine, ~500 MB plus memory with JVM. Rich transformation. Grok parsing, field mutation, enrichment, conditional routing, supports 200 plus input/filter/output plugins, runs as a centralized log processing tier. Common architecture. Deploy Filebeat on each node to collect and forward logs, then send to a centralized Logstash cluster for heavy parsing before indexing into Elasticsearch. This separates the lightweight collection from the resource-intensive processing.
What is the difference between pull and push monitoring models?
Pull model, for example, Prometheus. The monitoring system scrapes targets at regular intervals. Monitoring system controls the collection schedule. Easier to detect if a target is down, scrape fails. Example, Prometheus scraping.
/metrics.
Every 15s, push model, for example, stats_d, influx_db Datadog agent. Targets send metrics to a central collector. Targets control when and what to send. Better for short-lived jobs, serverless, and event-driven systems. Example, application pushing metrics to a stats_d server on each request, trade-offs. Pull is better for infrastructure monitoring. Gives the monitoring system full control and naturally detects failures. Push is better for ephemeral workloads, jobs that may finish before they can be scraped. Prometheus bridges this gap with the push gateway for short-lived jobs. Open telemetry is emerging as a vendor-neutral standard that supports both push and pull collection.
How does Prometheus handle high cardinality data?
High cardinality occurs when metrics have many unique label combinations, for example, per user or per request labels, causing memory and storage to explode. Why it's dangerous. Each unique label combination creates a separate time series. One metric times 10,000 user ID tickets equals 10,000 time series. This can crash Prometheus. Best practices. Avoid unbounded labels. Never use
User ID. Request ID. Email.
or
IP.
as labels. Use histograms/summaries instead of tracking individual events. Drop unnecessary labels via
Metric relabel configs.
monitor cardinality with
Prometheus DB head series.
and
Top.
queries, set retention policies, limit storage duration with.
Storage TSDB retention time.
Example, dropping a high cardinality label.
Code metric relabel configs, source labels, requested, action, label drop.
What are recording rules in Prometheus?
Recording rules pre-compute frequently used or expensive PROM-QL expressions and store the results as new time series. This improves dashboard load times and reduces query time computation. Example:
Recording rule XML. Code groups name, responsitim rules, interval, 30s, rules, record, job, HTTP request duration seconds, avgrade 5M. Expert AVG rate, HTTP request duration seconds some 5M. By job, record, job, HTTP requests, rate 5M. Expert sum rate, HTTP request total 5M. By job.
When to use recording rules: dashboard queries that scan many time series or long ranges, expressions used in alerting rules, pre-compute to reduce alert evaluation cost. Aggregations across many instances, /jobs, naming convention.
Level metric operations.
For example,
Job HTTP requests, rate 5M.
this is the Prometheus naming best practice.
What is Thanos, and how does it complement Prometheus?
Thanos is a CNCF project that extends Prometheus for long-term storage, global querying, and high availability. Core components: Sidecar runs alongside Prometheus, uploads TSDB blocks to object storage, S3, GCS, Azure Blob. Store Gateway serves historical data from object storage for queries. Querier provides a single PROM-QL endpoint that federates across all Prometheus instances and store gateways. Compactor downsamples and deduplicates historical data to reduce storage costs. Ruler evaluates recording/alerting rules against the global query view. Key benefits: unlimited retention via cheap object storage, global query view across regions, clusters, and clouds. Automatic deduplication when running HI Prometheus replicas, downsampling to 5M and 1H resolutions for old data. Alternative: Grafana Mimir, successor to Cortex, offers similar capabilities with a different architecture, horizontally scalable, multi-tenant by design.
How do you handle Prometheus high availability, HI?
Prometheus is a single-node system by design, so HI requires external coordination. Approach 1: identical replicas. Run 2 plus Prometheus instances scraping the same targets. Each replica stores its own copy of data. Use a load balancer or Thanos querier to deduplicate and merge results. Approach 2: Thanos/Mimir for deduplication. Thanos sidecar on each replica uploads data to object storage. Thanos querier deduplicates at query time using
Replica.
labels. Provides seamless failover. If one replica dies, the other still has the data. Approach 3: Cortex/Mimir, horizontally scalable. Prometheus writes via remote write to a centralized, distributed backend. Built-in replication, sharding, and multi-tenancy. Best for very large environments with 10M plus active series. For Alert Manager HI, run multiple Alert Manager instances in a gossip-based cluster. They automatically deduplicate alerts.
How do you enable authentication in Grafana?
Grafana supports multiple authentication methods, configured
Grafana NI.
or via environment variables, built-in methods, basic auth username/password enabled by default. OAuth 2.0, Google, GitHub, GitLab, Azure ID, Okta, generic OAuth. LDAP, Enterprise Directory Integration, SAML, Enterprise SSO, Grafana Enterprise. IP keys/service accounts, for programmatic access, example, GitHub OAuth.
Grafana NI.
Te-
Code auth GitHub enabled equals true, cliented equals your client ID, client secret equals your client secret, allowed organizations equals myorg.
Best practices: disable basic auth in production after enabling SSO.
Auth basic enabled equals false.
Use RBAC to assign roles viewer editor admin. Per team/folder, enable 2FI/MFI where possible. Use service accounts, not personal IP keys. for automation.
What are templating variables in Grafana?
Templating variables make dashboards dynamic by allowing users to select values from drop-down menus that are injected into queries. Variable types. Query populated from a data source query, for example.
Label values up job.
A custom, manual comma-separated values, interval time intervals.
1M, 5M, 15M, 1H.
A data source, switch between data sources dynamically. Ad hoc filters, automatically apply label filters to all queries. Example usage in a PromQL query.
Code rate HTTP prequest total job equals $service. Instance equals $, instance 5M.
Here,
$service.
and
$instance.
are dropdowns, the
Equals tilde.
operator supports multi-value selection with regex, chained variables. Variables can depend on each other, for example, selecting a
Namespace.
variable filters the available
Pod.
values.
How do you set up Grafana provisioning?
Provisioning allows Grafana data sources, dashboards, and alert rules to be managed as code via YAML files, enabling GitOps workflows. Data source provisioning.
Provisioning / data sources / default YAML.
Te-
Code API version 1 data sources name Prometheus type Prometheus URL HTTP / Prometheus 9090 access proxy it is default true name Loki type Loki URL HTTP / Loki 3100 access proxy.
Dashboard provisioning.
Provisioning / dashboards / default YAML.
Te-
Code API version 1 providers name default folder provisioned type file options path /var /lib /grafana /dashboards folders from file structure
Place JSON dashboard files in.
/var /lib /grafana /dashboards /
And Grafana will load them automatically on startup. Changes to the YAML or JSON files are picked up without restart.
What are Grafana, Loki, and Prometheus?
Loki is Grafana's log aggregation system, designed to be cost-effective and operationally simple. Key design principles. Index only metadata, labels. Not log content, drastically reduces storage and indexing cost, uses the same label model as Prometheus. Correlate metrics and logs using identical labels. LogQL, a query language similar to PromQL for filtering and aggregating logs. Prometheus is the default log collection agent for Loki. Discovers log files via static config or Kubernetes pod discovery. Attaches labels, job, namespace, pod, container. To log streams, pushes logs to Loki's HTTP API. Example Prometheus config.
Code scrape configs job name system static configs targets localhost labels job syslog path /var /log /syslog.
Alternatives to Prometheus. Grafana Alloy, the successor agent. Fluent or FluentBit with a Loki output plugin.
How can you monitor Kubernetes with Grafana?
The standard approach is the Prometheus Stack Helm chart, which deploys a complete monitoring pipeline. What it includes: Prometheus Operator manages Prometheus instances and scrape configs via CRDTKS.
Service monitor. Pod monitors.
A Grafana with pre-configured dashboards for cluster, node, pod, and namespace level metrics. Node exporter, hardware, and OS metrics from each node. Cube state metrics, Kubernetes object state, deployment replicas, pod phases, resource requests. Alert manager, pre-configured alerts for common failure scenarios. Installation.
Code Helm install kubeprom Prometheus community /kube Prometheus stack and monitoring create namespace.
For logs, add Loki plus Prometheus or Grafana Alloy. To ship container logs, then correlate metrics and logs in Grafana using shared Kubernetes labels.
What is an Elasticsearch shard, and why is it important?
A shard is the basic unit of storage and search in Elasticsearch. Each index is divided into shards that are distributed across cluster nodes. Shard types. Primary shards hold the original data. The number is set at index creation and cannot be changed later. Replica shards, copies of primary shards for fault tolerance and read throughput. Example, create an index with 3 primaries and 2 replicas.
Code curl-x put localhost 9200/logs pretty h content type application/json d settings number of shards 3 number of replicas 2.
This creates 3 primary plus 6 replica equals 9 total shards. Sizing guidelines, target 10 to 50 GB per shard for optimal performance. Avoid too many small shards, high overhead, or too few large shards, slow recovery, uneven distribution. Each shard consumes heap memory. A rule of thumb is max tilde 20 shards per GB of heap.
What is Index Lifecycle Management, ILM, in Elasticsearch?
ILM automates index management through defined lifecycle phases, optimizing storage cost and performance. Phases. Hot, actively written to and frequently queried, uses fast storage SSD. Warm, no longer written to but still queried, can be shrunk and moved to cheaper storage. Cold, rarely queried, can use frozen tier or searchable snapshots, frozen cheapest tier, data lives in object storage, searched on demand. Delete, automatic index deletion after retention period, example ILM policy.
Code policy phases hot actions rollover max size 50 GB maxage 1D. Warm minage 7D actions shrink number of shards 1 force emerge maximum segments 1. Cold's min age 30D actions allocate require data cold delete min age 90D actions delete
ILM is essential for managing log retention at scale. Without it, indices grow unbounded and degrade cluster performance.
How do you configure Logstash pipelines?
Logstash uses a pipeline architecture. Input, filter, output. Multiple pipelines can run in a single Logstash instance. Example.
Logstash conv. Code input beats port equals 5044 is filter grok. Match equals message equals %t imest impis 08601. Timestamp percentel oglevel. Level %greedyditi. Log message. Date. Match equals timestamp ISO 8601. Target equals at timestamp. Mutate. Remove field equals timestamp. Agent X. Output Elasticsearch. Hosts equals localhost 9200. Index equals applogs %+ YYYYM
Multiple pipelines define in.
Pipeline XML. Code pipeline ID, applogs path config, /etc /logstash /conf d /appconf, pipeline ID, system logs, path config, /etc /logstash /conf d /systemconf.
This allows different log sources to have independent processing rules, scaling, and error handling.
What are Kibana Canvas and Lens?
Lens, a drag-and-drop visualization editor, the fastest way to create charts in Kibana, automatically suggests visualization types based on the selected fields. Supports layers, formulas, and breakdown dimensions, best for day-to-day data exploration and standard dashboards. Canvas, a pixel-perfect, presentation-grade report builder. Uses a custom expression language for dynamic data binding. Supports custom CSS, images, backgrounds, and branded styling. Best for executive reports, NOC wall displays, customer-facing dashboards, when to use which. Use Lens for most monitoring and analytics dashboards, quick, flexible, data-focused. Use Canvas when visual design and branding matter, more than interactivity.
How do you configure Kibana security?
Kibana security is controlled through the Elastic Stack security features, formerly XBack. Enable security in
Kibana ML.
Eh.
Code XBack security enabled. True, Elasticsearch username. Kibana system, Elasticsearch password, $Kibana password.
key security features. Authentication, Native Realm, LDAP, Active Directory, SAML, OIDC, PKI certificates. RBAC, role-based access control with fine-grained permissions on indices, spaces, and features. Spaces, logical separation of dashboards and saved objects per team. Encrypted communications, TLS between Kibana and Elasticsearch. Audit logging, track who accessed what and when. Example role definition.
Code, cluster, monitor, indices, names, logs asterisk, privileges, read, view index metadata, applications. Application, Kibana, privileges, feature dashboard read, resources, space, production.
What is beats in the ELK stack?
Beats are lightweight, purpose-built data shippers that run as agents on servers to send operational data to Elasticsearch or Logstash. Beat types. Filebeat log files, the most commonly used beat. Metric beat system and service metrics, CPU, memory, Docker, Kubernetes, MySQL, etc. Packet beat network traffic analysis, HTTP, DNS, MySQL, Redis protocols. Audit beat, audit events, file integrity, system calls. Heartbeat, uptime monitoring via HTTP, TCP, and ICMP probes. Winlog beat, Windows event logs. Why beats instead of Logstash everywhere? Tiny footprint, ~10 to 30 MB memory. Safe to run on every node, each beat has built-in modules with pre-configured parsing and Kibana dashboards. Can ship directly to Elasticsearch, skipping Logstash, for simpler architectures.
What is Curator in Elasticsearch?
Curator is a CLI tool for managing Elasticsearch indices, automating tasks that would otherwise require manual API calls. Common actions: delete, remove indices older than N days. Close indices to free memory while keeping data on disk. Snapshot, create backups to an S3 or file system repository. Force a merge, optimize read performance by reducing segment count. Allocation, move indices to warm/cold nodes based on age. Example, delete indices older than 30 days.
Code actions 1. Action, delete indices, filters, filter type, age, source, creation date, direction, older, unit days, unit count 30.
Note in modern Elastic Stack 7, X+, ILM, Index Lifecycle Management, replaces most Curator use cases with a built-in, policy-driven approach. Curator is still useful for ad hoc tasks or legacy clusters.
How do you integrate Prometheus and ELK Stack?
There are several approaches to combining metrics, Prometheus, and logs, ELK, into a unified observability platform. Approach 1, Metric Beat with Prometheus module.
Code metric beat modules, module Prometheus, metric sets, collector, hosts, localhost 9090, period 10.
This scrapes Prometheus metrics and indexes them into Elasticsearch, queryable via Kibana. Approach 2, Grafana as a unified UI. Add both Prometheus and Elasticsearch as data sources in Grafana. Build dashboards that combine metric panels from Prometheus and log panels from Elasticsearch. Use Explore to correlate metrics and logs side by side. Approach 3, Prometheus remote write to Elasticsearch. Use
Remote write.
with an adapter to send Prometheus metrics to Elasticsearch, useful for long-term metric storage in an existing ES cluster. Best practice: use each tool for its strength. Prometheus for metrics alerting, Elasticsearch for log search, and correlate using shared labels and Grafana.
What is a slow query in Elasticsearch?
A slow query is any search that exceeds a configured time threshold, indicating performance problems. Enable slow query logging to identify problematic queries.
Code put /my index /settings, index search slowlog threshold query warn, 2s, index search slowlog threshold query info, 1s. Index search slowlog threshold fetch warn, 500 ms, indexing slowlog threshold index warn, 5s.
Common causes: wildcard or rejects queries on text fields, avoid leading wildcards.
Asterisk foo.
A deep pagination using
From 10,000.
forces ES to score all prior documents. Use
Search after.
instead large aggregations on high cardinality fields, missing keyword fields, sorting/filtering on.
Text.
Fields is slow. Use
Keyword.
subfields, too many shards. The query coordinator must merge results from all shards. Slow query logs are written to
Cluster index search slowlog log.
and can be shipped to ELK itself for analysis.
What is the ELK alternative to Prometheus and Grafana?
These are complementary tools optimized for different data types. Prometheus plus Grafana, best for metrics monitoring. Numeric time series data, CPU, memory, request rates, latency. PromQL for powerful metric queries. Lightweight, purpose-built for alerting on infrastructure and application metrics. ELK Stack, best for log management. Full-text search across unstructured log data. Rich Query DSL for complex log analysis, SIEM capabilities for security use cases, modern alternatives and complements. Grafana Loki, log aggregation designed to work with Prometheus labels, lighter than ELK. Open telemetry, vendor-neutral collection of metrics, logs, and traces. InfluxDB plus Telegraph, time series-focused metrics platform, Datadog/New Relic/Splunk, commercial all-in-one observability platforms. Grafana Tempo, distributed tracing backend, completes the metrics logs traces triad. Many organizations use both stacks. Prometheus plus Grafana for metrics and alerting, ELK for log search and compliance.
How do you scale Prometheus for a large environment?
Prometheus is single node by design, so scaling requires architectural patterns. 1. Sharding, horizontal partitioning. Split scraping targets across multiple Prometheus instances. Use hashmod relabeling or separate.
Scrape configs.
Per instance, in Kubernetes, deploy via stateful set with target partitioning. 2. Federation, hierarchical aggregation. Child Prometheus instances scrape targets and precompute recording rules. A parent Prometheus scrapes aggregated metrics from children via
/federate.
reduces the data volume at the top level. 3. Remote storage, long-term and global query. Thanos, sidecar plus object storage, S3/GCS, with a global query layer. Grafana Mimir, horizontally scalable, multi-tenant, stores in object storage, Victoria metrics, high performance, compatible with PromQL. 4. Optimizations within a single instance. Use recording rules to precompute expensive queries. Drop high cardinality labels via
Metric relabel configs.
attune
Storage TSDB retention time.
and
Storage TSDB retention size.
How does Prometheus handle stale or missing metrics?
stale markers. When a target stops reporting a metric, for example, a pod is deleted, Prometheus inserts a stale marker into the time series. This tells PromQL to stop returning that series in instant queries, preventing stale data from appearing in dashboards, detecting missing metrics with
Absent.
Eh.
Code absent upjob equals my service.
returns.
1.
If the metric doesn't exist at all, useful for alerting on missing targets.
Absent over time.
For intermittent gaps,
Code absent over time upjob equals my service 5M.
returns.
1.
If no samples exist in the last 5 minutes, dead man's switch watchdog alert, a recording rule that always fires, for example.
Vector 1s.
If Alert Manager stops receiving this alert, the alerting pipeline itself is broken. Services like PagerDuty and Deadman's Snitch can detect the absence of the watchdog signal.
What is Prometheus WIL ride-ahead log and its purpose?
The Ride-Ahead Log, WIL, is Prometheus's crash recovery mechanism for ingested samples. How it works. 1. Incoming samples are first written to the WIL on disk, append-only, sequential writes. 2. Samples accumulate in memory in a head block. 3. Every 2 hours, the head block is compacted into an immutable TSDB block on disk. 4. The corresponding WIL segments are then deleted. Why it matters. Crash recovery. If Prometheus crashes, it replays the WIL on startup to recover all samples that hadn't been compacted yet. Minimal data loss. Without WIL, all in-memory samples since the last compaction would be lost. Sequential I/O, WIL writes are fast because they are append-only. WIL files are stored in
data_dir/well/
and consist of numbered segment files, WIL-only mode.
enable feature equals agent.
Prometheus can run as a lightweight agent that only writes to WIL and remote writes to a central backend, Thanos Mimir, without storing local TSDB blocks.
What are histogram and summary metrics in Prometheus?
Both measure distributions, for example, request latency, but they work differently. Histogram counts observations into configurable buckets, for example, less or equal to 50 ms, less or equal to 100 ms, less or equal to 250 ms, less or equal to 500 ms, less or equal to ones. Exposes
Bucket. Sum.
and
Count.
time series. Percentiles are calculated at query time using
Histogram quantile.
can be aggregated across instances. This is the key advantage.
Code histogram quantile 0.95 sum rate HTT prequest duration seconds bucket 5m by la.
Summary precomputes percentiles quantiles. On the client side, exposes
Quantile equals 0.95. Sum.
and
Count.
time series cannot be meaningfully aggregated across instances. You can't average percentiles. Slightly more accurate for a single instance since there's no bucket granularity loss. When to use which? Histogram recommended default. Aggregatable, flexible bucket definitions can recalculate percentiles after the fact. Summary, only when you need precise quantiles from a single instance and don't need cross-instance aggregation.
How do you secure Prometheus endpoints?
Prometheus supports native TLS and basic auth since v2.24, plus network-level restrictions, native TLS plus basic auth.
WebIML.
Te-
Code TLS server config cert file /etc/Prometheus /Prometheus ERT key file /etc/Prometheus key basic auth users admin $2y $10 hashed crypt password.
Launch with
Prometheus web config file equals WebIML.
reverse proxy nginx/traffic. Terminate TLS at the proxy, add OAuth2 or mutual TLS authentication, rate limit query endpoints to prevent abuse, Kubernetes specific. Use network policies to restrict which pods can reach Prometheus. Use RBAC on the Kubernetes IP, to control who can port forward or access the service. Run Prometheus behind an ingress with auth middleware. Additional hardening, disable.
Web enable admin API.
And,
Web enable remote write receiver.
unless needed, use.
Web external URL.
To set the correct external URL behind a proxy.
How do you monitor Prometheus itself using Grafana?
Prometheus exposes its own operational metrics at.
/metrics.
These should be monitored to ensure reliability. Key self-monitoring metrics.
Prometheus DB head series.
Number of active time series, track for cardinality issues.
Prometheus PID chunks created total.
Chunk creation rate.
Rate Prometheus target scrape sexy dead samplelamidotal 5M.
Targets exceeding sample limits.
Prometheus target intervaling seconds.
Actual versus configured scrape interval.
Rate Prometheus rule evaluation fail arrest total 5M.
Failing recording / alerting rules.
Prometheus engine query duration seconds.
Query execution time, setup, 1. Add Prometheus as its own scrape target, it exposes.
/ metrics.
By default, 2. Import the official Prometheus overview dashboard from Grafana Labs, ID 3662. 3. Set up alerts on critical conditions, WIL corruption, high memory, scrape failures. For multi-instance setups, use Thanos or Federation to get a meta-monitoring view across all Prometheus instances.
What are Grafana annotations, and how are they useful?
Annotations overlay event markers on time series graphs, providing context for metric changes. Use cases: mark deployments, correlate a latency spike with a new release. Mark incidents, highlight downtime or degraded performance windows. Mark config changes, track when infrastructure was modified. Adding annotations. Manual click on a graph and add a text annotation, IPI.
Post / API / annotations.
With timestamp, text, and tags, query-based, configure a data source query that returns annotation events automatically. Example, automated deployment annotations via IPI.
Code curl x post http / grafana 3000 / API / annotations / h authorization bearer $grafana token / h content type application /json / d text deployed v2.4.1 tags deploy production time 1,700,000,000,000.
Integrate this.
Curl.
Call into your CI/CD pipeline so every deployment is automatically marked on all dashboards.
How do you configure Grafana for multi-tenancy?
Grafana supports several isolation levels for multi-tenant environments. 1. Organizations built-in. Each org has completely isolated dashboards, data sources, and users. Users can belong to multiple orgs with different roles in each, suitable for distinct teams or customers. 2. Folder plus team-based RBAC. Create folders per team, for example.
Backend. Platform. Security.
Assign folder permissions to teams, viewer, editor, admin. Data source permissions restrict which teams can query which data. 3. Multi-instance deployment. Run separate Grafana instances per tenant, full isolation of config, plugins, and data, higher operational overhead but strongest isolation. 4. Grafana Cloud / Enterprise features. Data source permissions restrict access at the data source level, reporting scheduled PDF reports per team. Enhanced RBAC, fine-grained permissions on dashboards, annotations, and alert rules.
What is alerting in Grafana, and how does it work?
Grafana's unified alerting system, Grafana 9+, provides a consistent alerting experience across all data sources. How it works. 1. Alert rules define a query plus condition, for example,
IVG CPU usage 80.
for 5 minutes. 2. Rules are evaluated at a configured interval, for example, every 1M. 3. When a condition is met, the alert transitions through states: normal, pending, firing. 4. Notification policies route alerts based on labels to the appropriate contact point, alert states: normal, pending, firing, no data, error. Contact points: Slack, PagerDuty, email, Opsgenie, webhooks, Telegram, Microsoft Teams, etc. Key features: silences, temporarily mute alerts during maintenance. Grouping, batch-related alerts into a single notification. Inhibition, suppress alerts when a higher severity alert is already firing. Multi-data source. A single alert rule can query Prometheus, Loki, Elasticsearch, and more. Example alert condition.
AVGs of query A5M now, 1000.
Fires when average request count exceeds 1,000 over a 5-minute window.
How does Loki compare with Elasticsearch for logging?
Loki and Elasticsearch take fundamentally different approaches to log storage. Grafana Loki indexes only labels metadata, stores log lines as compressed chunks. Extremely cost-effective, much less storage and compute than ES. LogQL label-based filtering first, then grep-like line matching. Designed for Kubernetes native environments with Prometheus-style labels, best for high-volume logs where you typically know which service/pod to look at. Elasticsearch builds a full-text inverted index on every log field. Powerful query DSL with fuzzy matching, aggregations, and complex Boolean queries. Higher resource requirements, CPU, memory, storage, but faster for ad hoc full-text search, rich ecosystem. SIEM, anomaly detection, a PM built-in. Best for complex log analysis, security investigations, compliance, decision guide. Choose Loki if you primarily filter by known labels and grep for patterns. Much cheaper at scale. Choose Elasticsearch if you need full-text search across unknown fields, complex aggregations, or SIEM features.
What is the hot, warm, cold architecture in Elasticsearch?
A tiered storage strategy that assigns nodes to different roles based on data age, optimizing cost and performance. Hot nodes, fast SSDs, high CPU/RIM. Handle all indexing, writes, and recent queries store the last hours to days of data. Warm nodes, cheaper storage, HDD or lower-tier SSD. Read-only data that is still occasionally queried. Indices are shrunk and force-merged to reduce resource usage. Cold nodes, cheapest storage, data may be partially cached. Rarely accessed logs kept for compliance or historical analysis. Can use searchable snapshots from object storage, S3/GCS. Frozen tier, newest edition. Data lives entirely in object storage. Fetched and cached on demand, cheapest option for long-term retention. Implementation. Use ILM policies to automatically transition indices between tiers based on age and node attributes.
No data, hot, warm, cold.
For shard allocation.
How do you reduce indexing pressure in Elasticsearch?
1. Tune index settings, increase.
Index refresh interval.
From
1s,
default to
30s,
or
60s.
reduces segment creation during heavy writes, set.
Index translog durability, async.
For higher throughput at the cost of potential data loss on crash. Disable replicas during bulk import.
Number of replicas, 0.
Re-enable after, 2. Optimize shard strategy. Avoid too many small shards. Each shard has fixed overhead, heap memory, file handles. Target 10 to 50 GB per shard and 20 shards per GB of heap as guidelines. Use ILM rollover to create new indices at a target size rather than daily. 3. Use bulk IPI. Always index documents in bulk, batches of 5 to 15 MB. Rather than one at a time, tune.
Bulk mix size.
In Logstash/Filebeat, 4. Pipeline and mapping optimizations, disable.
ZORs.
For metrics-only indices, if you don't need the original document, set.
Index false.
On fields you never search, use.
Keyword.
Instead of.
Text.
For fields that don't need full-text analysis.
How does Logstash manage backpressure?
Backpressure occurs when Logstash's output, for example, Elasticsearch, can't keep up with input volume. Logstash has several mechanisms to handle this. 1. Persistent queues PQ. Buffer events on disk when the output is slower than the input, survives Logstash restarts. No data loss.
Code QType persisted Qmax bytes 4 GB Q checkpoint trytes 1024.
2. Dead letter queue, DLQ. Events that fail to be processed, for example, mapping errors in Elasticsearch, are written to the DLQ for later reprocessing.
Code DLQ enable true DLQ max bytes 1 GB.
3. Internal backpressure. When the in-memory queue fills up, Logstash slows down input plugins, beats, Filebeat, MetricBeat. Automatically pause sending when Logstash signals backpressure. 4. Scaling out. Add more Logstash pipeline workers.
Pipeline workers.
Deploy multiple Logstash instances behind a load balancer.
What are query caching strategies in Elasticsearch?
Elasticsearch uses multiple cache layers to accelerate repeated queries. 1. Node query cache, filter cache. Caches the results of filter clauses.
Term. Range. Bool filter.
Shared across all shards on a node, automatically evicts with an LRU policy, size.
Indices queries cache size 10%.
Default. 2. Shard request cache. Caches the full results of search requests on each shard, only caches requests with.
Size 0.
Aggregation-only queries, automatically invalidated when the shard's data changes, refresh. Very effective for dashboards that repeatedly run the same aggregations. 3. Field data cache. Caches field values in memory for sorting and aggregations on.
Text.
Fields avoid use.
Keyword.
Or,
Doc values.
instead, field data is expensive and heap-heavy. Best practices, use.
Filter.
Context instead of.
Query.
Context where scoring isn't needed. Filters are cacheable. Monitor cache hit rates via.
Nodes/stats.
And
cat/nodes vnh equals name QCM QC.
query cache metrics.
How do you use Kibana for anomaly detection?
Kibana's machine learning feature requires at least a basic license. Detects anomalies in time series data automatically. How it works. 1. Create an anomaly detection job that learns normal behavior patterns. 2. The ML model identifies deviations from the baseline. 3. Results are displayed with anomaly scores 0 to 100. On a timeline, example job configuration.
Code analysis config. Bucket span 15M. Detectors. Function mean field name. Response time partition field name. Service. Data description time field at timestamp.
Common detector functions.
Mine. Count. Sum. Rare. Freak rare. High count. Low count.
Use cases. Detect unusual spikes in error rates or response times. SIEM. Identify anomalous login patterns, unusual network traffic, or privilege escalation. Infrastructure. Spot unexpected resource usage per host or container. Anomaly results can trigger alerting rules that notify teams via Slack, email, or webhooks.
How do you secure Elasticsearch clusters?
1. Enable security features.
Code #Elasticsearch shiml XBAC security enabled. True. XBAC security enrollment enabled. True.
In Elastic 8, X security is enabled by default with auto-generated passwords and certificates. 2. Encryption. TLS for transport layer, node-to-node communication. Mandatory in production, TLS for HTTP layer, client-to-node. Encrypts IPI traffic, auto-configure with.
Elasticsearch certutil.
Or bring your own CI. 3. Authentication, native realm built-in users. LDAP, Active Directory, SAML, OIDC, PKI certificates. IPI keys for service-to-service communication. Use.
Elasticsearch reset password.
To manage built-in user credentials. 4. Authorization, RBAC. Define roles with index level, field level, and document level security. Restrict which indices a user can read/write, and even which fields they can see. 5. Network security, bind to specific interfaces.
Network host.
A. Use firewalls or security groups to restrict port access. 9200, 9300. Deploy behind a reverse proxy for additional auth layers. 6. Audit logging, enable.
XPack security audit enabled. True.
To log all access and changes for compliance.
How do you integrate Prometheus with Elasticsearch?
Option 1, MetricBeat Prometheus module. Push Prometheus data into ES.
Code MetricBeat modules, module Prometheus, metric sets, collector, hosts, localhost 9090/metrics, period 10s output Elasticsearch, hosts, localhost 9200.
This scrapes the Prometheus
/metrics.
endpoint and indexes the data in Elasticsearch for analysis in Grafana. Option 2, Prometheus Remote Write to Elasticsearch. Use a remote write adapter or Elastic's native Prometheus input. Sends all Prometheus metrics to ES for long-term storage and Grafana visualization. Option 3, Grafana as a unified layer. Add both Prometheus and Elasticsearch as Grafana data sources. Correlate metrics, Prometheus, and logs, Elasticsearch. In the same dashboard, this is the most common and recommended approach. Option 4, Open Telemetry Collector. Collect metrics and logs in a vendor-neutral format, export to both Prometheus for metrics alerting and Elasticsearch for log analysis simultaneously.
How do you optimize Elasticsearch queries for performance?
1. Use filters over queries.
Filter.
Context skips scoring and is cacheable. Use for exact matches, ranges, and Boolean conditions.
Code query bool filter, term status, error range, at timestamp, GTE, now 1H.
2. Avoid expensive operations. No leading wildcards.
Asterisk arrow.
They scan every term in the index. Use.
Search after.
Instead of deep.
From.
Pagination, avoid.
Script.
Queries and hot paths. 3. Use the right field types.
Keyword.
For filtering, sorting, and aggregations, not.
Text.
Bleh.
Doc values.
Enabled by default on keyword/numeric. Columnar storage for fast aggregations, disable.
Zors.
Or use.
Zors.
Filtering to reduce response payload. 4. Optimize aggregations. Filter before aggregating, narrow the dataset with a date range first. Use.
Composite.
Aggregation for paginating large bucket lists. Pre-aggregate at index time using ingest pipelines when possible. 5. Index design. Use time-based indices with ILM for rollover. Right-size shards, 10 to 50 GB. To balance parallelism and overhead. Use.
Index sort.
To collocate documents and enable early query termination.
How do you implement centralized logging in Kubernetes?
Common architecture.
Code pods stdout/stdare, node level agent daemon set, aggregation, storage, visualization.
Option 1, ELK Stack, Elasticsearch plus Fluent plus Grafana. Deploy Fluent as a daemon set that reads container logs from
/var/log/containers/.
Fluent parses, enriches with Kubernetes metadata, and forwards to Elasticsearch.
Code match a type Elasticsearch, host Elasticsearch logging SVC, port 9200, logstash format true, include a tag key true/match.
Option 2, PLG Stack, Prometheus plus Loki plus Grafana. Deploy Prometheus or Grafana Alloy. As a daemon set, automatically discovers pods and attaches Kubernetes labels. Sends logs to Loki. Query in Grafana with logql, much lighter on resources than ELK. Option 3, Filebeat plus Elasticsearch. Filebeat daemon set with Kubernetes auto-discover. Built-in modules with pre-configured parsing for common apps. Best practices. Use structured logging, JSON, from applications to avoid complex parsing. Set resource limits on logging agents to prevent them from starving application pods. Implement log retention policies, ILM or Loki retention, to control storage growth.
What are the best practices for log retention and compliance?
1. Define retention policies by data classification, security/audit logs, 1 to 7 years depending on compliance. SOC2, HIPII, PCIDSS, GDPR. Application logs, 30 to 90 days typically, debug/trace logs, 7 to 14 days, 2. Automate retention with ILM. Use Elasticsearch ILM to move indices through hot, warm, cold, delete phases in Loki configure.
Retention period.
And
Compactor.
for automatic cleanup, 3. Protect sensitive data, mask PII, personally identifiable information. At ingestion, use Logstash.
Mutate.
Or ingest pipelines to redact emails, SSNs, credit card numbers, encrypt data at rest. Enable encryption on Elasticsearch data directories and object storage. Encrypt in transit, TLS between all components, 4. Access control. Use RBAC to restrict who can view which indices. Enable audit logging to track all access to sensitive log data. Implement field-level security to hide sensitive fields from unauthorized users. 5. Backup and disaster recovery. Use Elasticsearch snapshots to S3/GCS for backup. Test restore procedures regularly. Keep snapshots in a separate region for disaster recovery.